All right, welcome to our area model multiplication video. This is just in case you happen to miss class or you didn't get to hear this lesson and want to see it again. This is all about using a picture, using an area model to help us understand how we can multiply fractions together. So it's in your note packet. We've already got our essential question. How can you use an area model to understand multiplication of fractions? In your notes here, you're going to see this left-hand side, you're going to kind of see a set of boxes going down the page. This next part I show you is kind of following those boxes down the page. I'm kind of modeling how I'm going to do the problem. After I talk you through one, then you're going to do one over on the right-hand side in your notes. So we're just kind of following along. And then the second page has some additional ones that we're going to do for you. So we want to do the problem 1/2 times 1/4. So the first fraction goes out to the side. And basically think of it as we're going to color in half of the rectangle. So coloring in half. If you look in your notes, it's that next box down. You'll see the 1/2 off to the side, and then your half of it is colored in. We want to find 1/4 of that 1/2. So my other fraction is going to go along the bottom. And basically I'm going to do the same thing. I'm going to color in 1/4 of it, but this time I'm going to break it up going up and down. So I'm going to break it up into 4 parts. And I'm going to color in one of those 4. So basically we're coloring in 2 fractions. They just happen to be overlapping. We're drawing them both on the same rectangle. The key to the whole problem is this corner down here. Notice how it was yellow and then it got colored blue. So it kind of got colored twice. It's part of the 1/2 and it's part of the 1/4. That's the key to the whole problem. The number of squares that got colored in twice, that's my numerator. The whole number of squares, 1, 2, 3, 4, 5, 6, 7, 8, that's my denominator. 1/4 of 1/2 is really 1 out of the 8 total pieces. Okay? Now, if that's a little tricky so far, totally okay. We're going to go through a couple of examples. But the whole idea is we're modeling in a picture form what's happening in our multiplication. We're finding part of something else. So here, 2/3 times 3/5. So I always start with my first fraction out to the side. I want to shade in 2/3 of this rectangle. Well, your denominator is how many parts you're going to break it into. So I want to break it up into 3 parts. Oh. And I want 2 of them. So I'm going to shade in 2 of those 3. Obviously, your coloring can be much better than mine. Now, I've got 2/3 of something. So not all of it, part of it. But now I want to find 3/5 of it. 3/5 is just part. So I want part of this part down here. And I know that sounds complicated, but we really just want a piece of something that's already a piece. So we're kind of finding a smaller part to it. In this case, I want fifths. So I'm going to break it up into 5 equal parts. Again, draw it as evenly and as neatly as you can. It's a little tougher for me to draw straight lines here, but I do my best. And I want 3 of them. So I'm going to shade in 3 of them all the way top to bottom. I'm basically shading in 3/5 of my rectangle. So I shaded one fraction going one way, I shaded the other going the other. And I know that second one can be complicated because it's hard to draw on top of the one that's already there, but it just takes some practice. But the key is the bottom 2 rows, that was my 2/3, and I want 3/5 of that. So I want 3 out of the 5 pieces. So what I really want is this part right here, the part that was my 2/3 and my 3/5. I call it my overlap or my doubled up parts. There are 6 squares total that got doubled up. There are 15 squares total. Colored, uncolored, we don't care. There's 15 total. So 6 is my numerator, 15 is my denominator. And then, like any good fraction problem, always check to see if you can simplify. 6 and 15 can each be divided by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. And my final answer is 2/5. Now, you might be thinking, well, Mr. McKenzie, couldn't I have just done 2 times 3 is 6 and 3 times 5 is 15? Yeah, that's what you're going to learn in that next lesson or what you might have already talked about. But the whole point of today is I don't want you to just take my word for it that you just multiply numerators and multiply denominators. I want you to be able to come up with a picture that proves why that really does work, because we would have gotten that same answer. So in your notes down at the very bottom, you're going to see a box that says solution, and then there's a bar cutting right through that box. Okay, we're going to write a little cheat sheet. After I've drawn my area model, how do I find my answer? How do I write that answer? So down in that bottom box, here's what I want you to write. On top of the line, so think of it kind of like a fraction, in the numerator, the number of boxes shaded in twice. Yes, that's the number sign, not hashtag. Okay, that stands for number. Number of boxes shaded in twice, my overlap. The number of boxes in total, the total number of squares in the whole thing, goes on the denominator. But that's how I create my answer. That's how I get my fraction. All right, flipping your notes over to the back side, we're going to do another one together. This one's right at the top of the page. So we're going to do 3/4 times 3/5. So I always like to put my first fraction out to the left, and my second one goes along the bottom. And in this case, I've actually done the dividing for you. You'll notice that I broke it up into 1, 2, 3, 4 parts, because I want fourths. I'm going to color in 3 of them. So, not the best coloring, but you can kind of see which rows I'm coloring in, just to save a little bit of time. Then, I'm going to do my other fraction going up and down. I'm switching directions. I want fifths, so I broke it up into 5 equal parts, and I want 3 of them. So I'm going to shade in 3. Okay? Avoid the temptation to make cool patterns with the bars. Don't color 1 and then skip 1 and color 1 and skip. It's harder to see your answer when you do that. You could do the left 3, you could do the right 3, but try to put all 3 bars or all 3 boxes together. When I'm done, now I go back and I focus on the overlap. Where do I see both colors shaded in? Well, in this case, there are 9 boxes that got shaded in twice. All together, if I count all of my boxes, I've got 5 and 5 and 5 and 5. That gives me a total of 20. 3/4 times 3/5 is equal to 9/20. All right, so this should be the next one down in your notes, down and to the left. It's kind of taller than it is wide, and we're going to do this problem here. Ruby biked a trail that is 3/5 of a mile each way. After biking 1/4 of the trail, she stopped to rest. What fraction of a mile did Ruby bike before she stopped to rest? So her bike trail was 3/5. Oh, probably not my best color. Let me pick a different one. So 3/5 of a mile is how long the whole ride was. But she only did 1/4 of the trail. So when you see the word of, I want you to think multiply. I want 1/4 of something, so I want to multiply it times 1/4. So I want to do the problem 3/5 times 1/4. So I start with my 3/5 out to the side and my 1/4 along the bottom. 3/5 means I want to break it up into 5 equal parts, or close to equal. Hopefully your lines are better than mine. And I want 3 of them. So I'm going to shade in 3 of my lines. You can do a much better job of shading all the way in for me. Then going up and down, I want 1/4. So that means I'm going to break it up into 4 parts. Sorry, that was a horrible line. So I broke it up into 4 parts because I want fourths, and I just want 1 of them. So I'm going to shade in 1/4. So here's how I want you to think about it. The trail was only 3/5 of a mile, so it wasn't the whole mile, it was just part of it. And she only did part of that trail, so she only did a small little part of something that was already less than a whole mile. So we're expecting to get a smaller number, because she biked a smaller amount of that 3/5 of a mile. Well, there are 3 squares total that got colored in twice. Altogether, there are 20 squares. So she biked a total of 3/20 of a mile. Makes sense? 3/20, not very much, because she only did 1/4 of the trail. Oh, I'm going to go back to this one. All right. Oh, clicking the wrong one. All right. So this one should be the next one down in your, or next one in your notes. It's over on the right-hand side. It's wider than it is tall. So this one said, in Mr. Mackenzie's library, 1/3 of his books are nonfiction. Chances are it's probably higher than that, but that's what I used for the example. Of my nonfiction books, 3/4 are about math and science. So 3/4 of The nonfiction books are about math and science. Well, when I want to find a fraction of something, that really means I want to multiply. So I want to do 1/3 times 3/4. So I'm going to put my 1/3 out to the side, meaning I'm going to break it up into 3 parts. And I just want one of them. So picture this is my big bookcase at home. This whole bottom row, 1/3, are my nonfiction books. Now, of this part of my library, 3/4 of them are about math and science. So I'm going to put my 3/4 down here, meaning I'm going to break it up into 4 equal parts. That's a really good line. That means my next one's going to be terrible. So 3/4, I want 3 of those 4. So 1, 2, and 3. So this bottom row, that's 1/3 of my library. And then these 3 chunks, 3 out of the 4 chunks, are my math and science books. So I want to know what fraction of the whole library is it. Well, there's 3 squares that got colored in twice. There are 12 squares total. So I got an answer of 3/12. But I always check to see if I can simplify. In this case, 3 and 12 can both be divided by 3. And I get an answer of 1/4. So 1/4 of the whole library is this small little section of my math and science books. All right, hopefully you're feeling pretty good about this. Hopefully you got a pretty good idea. If not, go back, rewatch one of the examples. But here's our last little bit. Can we go backwards? Can you read what was colored in and what problem were we actually trying to do? And this part can be a little tough. So I always start out to the side. How many rows, how many stripes did I divide it into? Well, I broke it up into 4 parts. The numerator is how many got colored in. Now by colored in, it's all the way left to right. I colored the whole stripe in. In this case, I only colored this one row all the way. So that must have been a 1/4. Now going up and down, there's 1, 2, 3, 4, 5 stripes. And then 1, 2, 3 of them got colored all the way top to bottom. So 1/4 times 3/5. My answer is how many got overlapped. That's kind of my cross hatching down here, kind of showing you where the 2 grays overlapped. 3 squares got colored in twice, and there are a total of 20 squares altogether. So this was the problem. 1/4 times 3/5 equals 3/20. All right, over here, start on the left-hand side. 1, 2, 3, 4, 5 stripes. So I'm dealing in fifths. 1, 2, 3 of them got colored in all the way left to right. So just coloring a little of it doesn't count. I want the ones, the whole stripe is colored all the way. Then going up and down, I've got 1, 2, 3 stripes, so thirds. 1, 2 of them are shaded all the way top to bottom, 2/3. So I'm doing the problem 3/5 times 2/3. There's 1, 2, 3, 4, 5, 6 squares that got colored in twice. Total, I've got 3, 3, 3, 3, 3. That's 15 total pieces. And then, of course, I always check to simplify. 6 and 15 will both be divided by 3, and I get 2/5 as my answer. All right, so hopefully you got a pretty good handle on using area models to show why multiplying fractions works the way that it does. If not, go back, rewatch an example or two, and see me with questions.